Section 5 is going to look at some additional properties of similarities, which really are going to boil down creating those proportions of corresponding parts to corresponding parts. The trick is just always making sure that you're comparing apples to apples and oranges to oranges when you write those proportions. So we've already talked a little bit about similar triangles, and similar triangles are going to have all corresponding angles equal and all corresponding sides will be proportional. So that hasn't changed. And we can write that triangle congruence statement or similarity statement, excuse me, like a congruence statement that helps me understand how things line up. So in this case, the triangles below are similar, and so it's pretty easy to see that we have a leg compared to a leg and the hypotenuse compared to the hypotenuse. And so we can go ahead. There are different ways to write these proportions, but again, make sure you're consistent with how you write your proportions. So I'm going to say leg to leg is going to be equal to the hypotenuse to the hypotenuse. And I'm very careful to make sure that I have triangle CFA coordinates both in the numerator, triangle DFB coordinates in the denominator. So we're going to do our parentheses. When we cross multiply, we have 24x plus 24 is equal to 40x minus 20. When I subtract 24x from both sides and add 20, I end up with 44 is equal to 16x. And when I do that division, I end up with x is equal to 2.75 units. Additionally, we can do this to real life problems. If I have shadows and the heights of two items, I can go ahead and calculate the height of the taller item. And so if I have the item's height to its shadow would be at the same proportion as the person's height to his or her shadow. And when I cross multiply 105 equal to 7x, I end up with x is 15 feet, which makes sense because this should be the bigger of the two dimensions. Now, triangle proportionality theorem. At first glance, this might look a lot like the triangle midsegment, but remember in triangle midsegment, that parallel side was connecting the midpoints of the opposite sides, and then we had some unique things happening. In this case, it is not at the midpoint, so it is going to divide the sides into segments of proportional length. So I can say that NY is at the same proportion as NB, this piece and this piece, as YJ is to JK. Or, so I took piece compared to piece, piece compared to piece. I could also do a whole compared to either piece. But again, make sure you are comparing apples to apples. So if I say that this smaller NB compared to its entire side of BY is going to be at the same rate, same proportion as JK is to its entire side of KY. So just be sure you are writing equivalent proportions when you do this. Another cool factor is if I have an angle bisector, note right here, my angle gets bisected, it actually creates proportions of the segments. And the segments that are proportional are the long outside leg to its bottom and the long outside leg to its bottoms. So I get this PR is proportional to RL at the same rate as PQ is to QL. Because remember, angle bisectors tell me nothing about the base. So if we look at this example, I know that 5 and 3.5 are going to be at the same proportion as 12 and x. So I can write 5 over 3.5 will be equal to 12 over x. Notice I was careful to put the sides on the numerator and the pieces of the bottom on the denominator. When I do that cross multiplying, I end up with 5x is equal to 42, and x ends up being equal to 8.4. Much of this proportionality stuff should feel like common sense. When we talk about proportional parts of parallel lines, if 3 or more parallel lines are intersected by 2 transversals, they cut off the transversals proportionally. So again, I can write these proportions of pieces from one side of the transversal to the other. So I can say that DE compared to AB will be at the same proportion as EF is to BC. Or I can go ahead and I could use the entire thing and one of the pieces. So I could talk about DE compared to DF would be at the same proportion as AB is to AC, a part to a whole, a piece to a longer piece, but again, everything is being compared fairly. Here, I kept the sides in the numerator. Here, I kept the sides in the same fraction. Again, when you cross multiply, it ends up the same. So tune into the next video to watch this example.